Hello class, this is a video tutorial on binomial expansions part 1. In this video I'm just going to give you an introduction to what a binomial expansion is, and hopefully we'll see one of many patterns that we'll see from these expansions. So here we go. A binomial expansion is a group with two terms raised by a power. So one term, two terms, it's in a group, it's raised by a power. Here we go. One group with two terms raised by a power. One group with two terms raised by a power. I'm sure you get the idea. So let's expand up to the fourth power to establish a pattern. And we'll apply a simpler method to expand the nth power for any binomial expansion. So far we're doing a very simple expansion of x plus y. Later on we can use any term on the inside, so we might have 2x plus square root y to the power of 10. And we'll learn how to expand something like this, which is very difficult to do by hand, but we'll see a quick way of doing it. So here we go. Let's expand these first ones first. X plus y all to the power of 0. Hopefully you can recall that anything to the power of 0 is 1. X plus y to the power of 1. Well, what this really means is just x, like one group of x plus y. That's really just x plus y. Now, I'm going to draw your attention to a few things here. I'm going to highlight it in orange. To the power of 1, to the power of 1. The coefficient of each are 1 and 1. We normally don't write these, but I'm going to emphasize these to sort of hint at you what you should be looking at. Okay, so that's the expansion of the first two. Power of 0 and the power of 1. For this one, well, if you can recall quick ways of doing it, I'm going to show you the long form of doing it. X plus y, x plus y. It literally means two groups of the same thing multiplied. Multiplying this out, x times x becomes x squared. X times y becomes x y. Y times x, we can just write it as x y, plus y times y is y squared. We're going to simplify this and write it as x squared plus 2xy plus y squared. Once again, I'm going to emphasize these. That's 2, 1, 1, 2, and the coefficients are 1, 2, and 1. Okay, let's keep moving on to the next one. Let's move these up. These are going to get slightly more difficult, but we'll proceed as follows. This literally means three groups of x plus y, like so. 1, 2, and 3. Fortunately though, we already know the expansion of this because these two is x plus y squared. So we could easily replace that with the following. X plus y outside of this expression here. That's x squared plus 2xy plus y squared. And we're going to expand that one very carefully. Like so. Take a look. X times x squared is x cubed. X times 2xy, that's going to become plus 2x squared y. X times y squared is going to become xy squared. And we're finished with that expansion. Let's now move on to the y multiplication. Y times x squared. Now I usually like writing it on another line, but I'm going to match the like terms like so. Take a look. Y times x squared is going to become x squared y. Y times 2xy is going to become 2xy squared. Notice how it's already matching up like terms. Makes it a lot easier later on. Y times y squared is going to become y cubed. Adding like terms, x cubed plus nothing, it's x cubed. 2x squared y plus 1x squared y is going to become 3x squared y. Same for this, it's 1xy squared plus 2xy squared. That's going to become 3xy squared plus y cubed. I'm going to draw your attention again to the powers. 3, 2, 1, 1, 2, and 3. As for the coefficients, it's 1, 3, 3, 1. Okay, let's move on to the last one for this exercise. We're definitely not going to be expanding this one. That's very, very difficult. It'll take a very long time. So once again, this is the exact same thing as the previous, except instead of just 3, there's going to be a fourth one. But as you've noticed, these 3 is just x plus y cubed. We already have the expansion for that. It's right here. So we could rewrite this question more simply as x plus y cubed. But since we already know the expansion of that, we're just going to write that one in. I'm going to be a little bit lazy, and I'm just going to copy it out like this. Thank goodness I have an iPad, because writing out that again would have taken quite a while. Let's ignore the coloring. Whoop. Oh, let's just ignore the coloring for now. Get rid of that one, get rid of that one, and let's expand this. X times x cubed, x to the power of 4. X times 3x squared y is going to become 3x cubed y. Multiplying these very carefully, x times 3x y squared is going to become 3x squared y squared, and x times y cubed, or just 1y cubed, we can ignore that one, that's going to become plus xy cubed. We're finished with multiplication of x. Let's move on to y. Y times x cubed is going to become x cubed y. Once again, notice how I'm using a new line and lining up like terms already. Makes it a lot easier. Plus y times 3x squared y. That's going to become 3x squared y squared. Y times 3x y squared. It's going to become 3x y cubed. And lastly, y times y cubed. That just becomes y to the power of 4. Collecting like terms, x to the power of 4 plus nothing is x4. 3x cubed y plus 1x cubed y, that becomes 4x cubed y, plus 3 plus 3, these are already like terms, that becomes 6x squared y squared. plus 1xy cubed plus 3xy cubed. That becomes 4xy cubed plus y to the power of 4. I'd like to draw your attention again to the powers. 4, 3, 1, 2, 2, 1, 3, 4. As for the coefficients, 1, 4, 6, 4, 1. So that's all for this video. The main thing here is that you now know how to further expand larger binomials, and hopefully by me pointing out the patterns in the indices as well as the coefficients, you have something to look for in the next few videos. Okay, so keep an eye out for the patterns in the powers as well as the coefficients. Okay, I'll see you in the next video. Best of luck.